The following presentation was recorded at the 2016 Southeast Linux Fest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the Southeast Linux Fest, please visit www.southeastlinuxfest.org. The Southeast Linux Fest would like to thank the following diamond sponsors in 2016 for helping make these videos possible.
I'm Underwood. This talk is behind the scenes of SELF 2016 AV and networking. Unfortunately, Noah is not going to be able to join us like the program says. It is the 10th anniversary of his show, so he flew back to Seattle last night to do the show. So I am going to cover some of the OBS and the AV side. I'll do my best. It was not my area. So this talk's probably going to be a lot more heavy on the networking, the wireless, but a little bit of the AV. So a little bit about me. This is my third year doing SELF. The first 2 years was sponsored by an employer at the time. I am now here on my own volition, and the networking hardware for this event, particularly the access points and switches, was provided by Noah's company, Alt iSpeed. I've worked for many different companies, from a wireless ISP to a data center to a county library system. My current employer is a retail point-of-sale vendor. We make, deploy, design retail point-of-sale, mostly for the grocery store market, but we do have many boutique type mall-style clients. My background is mainly Linux, networking, and VMware. I'm a Red Hat certified engineer for version 6, a certified systems administrator for RHEL 5, 6, and 7. I would love to go get my VCP if an employer wants to sponsor me for that, but that is outside of my price range. For networking, I've done everything from basic small office networks to large ISPs, doing dynamic routing with BGP and OSPF. The largest network is probably when I worked at the ISP. We had probably about 60 or 70 routers, probably that many switches, and we had started to take over the management of our clients' networks. So that was growing our footprint. Also, before we move on, if there's any questions, just speak up and I'll raise your hand and I'll address them and fly. So this year's network is the best that we've had so far. Other than a few hiccups on Friday, which I'll get to, we have had a very stable network. The network, also, disclaimer, I am a Ubiquiti stock owner. This does not affect my decision in the use of the equipment. I need to disclose that. So we are using 7 Ubiquiti AC Pros. These are dual band, triple channel. These go for about $200 and something retail. They are PoE standard. They also use the Ubiquiti PoE type. They run on a central controller, and the product line is the Unify, and the controller is therefore the Unify controller. The controller allows us to manage all the access points from a single dashboard and not have to log into each individual access point and dig around to make changes. So the 7 access points, there's actually one up here on the floor. The ones in the ballroom are visible. There is one in each ballroom, and they are named according to the ballroom they're in. So this is the Google AP. So we have 4 in the ballrooms. There is one that is tucked in the ceiling of the Linode room. There is one that is sitting on a table in the command center. There is one that is sitting in the junior ballroom, which was called the Pogo Hospitality Room, which is over by registration. It's tucked up in the ceiling. And then there is the Unify In is an older AP. That's my That was actually my AP when I upgraded, so I brought it here. That's actually tucked up in the ceiling in the bar area. For the switches, I'm very bullish on the HP 1910s. They are the old 3Com switches. It's a 24-port all-gigabit switch with current HP firmware. I think the firmware is actually from this year. But these switches can be picked up on eBay for about $100 a pop. And they're fully managed, layer 3 routed, so I'm very bullish on these.
What's your power footprint, power use?
I'm not exactly sure the power use of these switches. They are a rack mount power switch, rack mount switch, non-PoE. So I would imagine it's less than 100 watts.
But not 5 watts, 8 watts.
No, it is a rack mount switch. For cabling, we brought 2,000 feet of cable. We ended up using about 1,500 feet, and most of that is actually here in the ballrooms. Every ballroom has 2 laptops, one speaker, one room moderator, video controller, whatever his title is today. Each one of these laptops has a hardwired cable back to a switch that is tucked in the Pocona room. In the back of the Pocona room, which is basically follow the cables straight under the air wall. In the back, there's a switch, and all the cable runs from all the ballrooms will aggregate back to that switch. And that is so that we don't have to then carry those cables across the hall over to knock. Between the switch at knock and the switch in the ballroom, we're running lag. I'll get to that a little later. So when I mentioned about the hiccups on Friday, that's why the PF census crossed out. I had brought a 1U Sun server that was running the latest release of PF Sense, which is a firewall router distro, open source based on FreeBSD. And two times Friday, the LAN decided to stop responding to pings. We're running, it's a single physical interface with multiple VLANs. And every one of the VLAN IPs dropped out and was no longer pingable, and it took a reboot of the box to get it back. So I don't know, I didn't have time to troubleshoot it, whether it was a hardware or software, but I brought a Ubiquiti Edge Router Lite with me, which is a $100 router. I'll get to that in a second. That I swapped out into place early Saturday morning, and it's been running great since then. The Ubiquiti Edge Router Lite is a $100 router, 3 gigabit ports, and runs a slightly modified version of IATA, which is a Debian-based distro. You can log into that router and do sudo space su dash and get a root prompt. There's nothing, they don't try to hide it, they're not trying to obscure it. And once you're in root prompt, you can then apt-get and install your own Debian packages. Yes?
Does it support Ansible?
I do not know.
Repeat question.
The question was, does it support Ansible?
It's basically a Python. Is there enough Python on there for Ansible?
You can install whatever Debian packages you would like that are architectural independent. It is running a MIPS-based, the Edge Router Lite is a 500 megahertz dual core MIPS-based processor. So possibly it could run it. The next is we have quite a few VMs, and it's actually more than on this slide. There's actually 4 VMs that are running on a IBM server. And don't poo-poo me, it's ESXi, yes, it's not free, open source, but I could set the server up in about 5 minutes. So that's why it is. Like I said, there's 2 VMs. One VM is for CentOS. It's CentOS 7 that runs Zabbix, and the other is a Ubiquiti Ubiquiti 1604 for the Unify software. For the internet, we did a 300 by 20 coax service from Time Warner, and so far we have peaked at about 150 down. and about, we probably come close to maxing the 20 out, 20 upload. And like I said, there's 8 laptops for video capture. That's been an interesting experience with these laptops. Yes?
You got traffic shaping on the upstream side?
So the original plan was to do traffic shaping, and I'll get more into traffic shaping with QoS. But because the streaming did not, because we're not actually doing live streaming because of some technical hiccups, I decided to strip away the QoS and filters so that it did not create one more hurdle. The question was, are we doing traffic shaping? And the last piece of hardware is actually my gaming desktop that I brought that I installed Ubuntu, which does aggregation of all the videos and also runs the pre-display that's sitting outside the command center. And yes, that is Windows 10 when it's not Ubuntu. So Zabbix. Zabbix is an open source monitoring platform. There's a lot in this field. And I chose Zabbix because of its, someone had wrote an add-on to Zabbix that would support the Unify platform. And thus far, it's the only management platform that I know of in the open source world that supports the Unify platform. And since we'd be using Unify access points, that was the #1 feature. So, let me go. This is Zabbix itself. And I've created some scenes to try to make 3D charts. And this is what loops, these are the same charts that loop at command and up. I'll just go over them a little bit. The screen resolutions. So this is using the DHCP. It was working Friday, and then when I changed the router, I could not get DHCP relay working, so I had to scrap the Linux-based DHCP server in favor of the Ubiquiti doing the DHCP. So this was working a lot better, and basically there is a Zabbix agent that runs on the DHCP server, which will just run just do a WC and basically count how many entries are in the DHCP base file. So that's pretty basic. The next statistics that it's drawing is, this is from Bind, again through the Zabbix agents. And this is, my understanding of these data is, this is the number of lookups per second that the network as a whole is doing. And
there's a graph there.
yes, there is a graph there, and unfortunately it's not showing very well, but you can look at the table data. We hit at the most, we were doing 17 A-record lookups per second. And that is from the public wireless, the video network, the staff network, and the servers. And then also some cool information is it can get back what type of, whether the request was rejected, successful, the domain not found, the server not found, and then also it can pull the DNSSEC information, so you can see whether there was any failed validations. And again, this is all open source. Let's see if this next graph shows up better. That one's on. So this particular information, God, the colors are horrible. This next information is being pulled via SNMP, and this is aggregating on our different networks. So we can basically, with this, see what the traffic load is on a per network, per VLAN basis. And for y'all's reference, the VLAN 100 right here is the public network. And as you can see, in most cases, it is the leader in the volume of data being downloaded. And on the wireless, we get over 100 megs concurrent download. Where Zabbix really shined for me, and the reason I ended up choosing it, is because of the Unify information. That's actually wrong better. So that is actually the number of clients per AP over a given time. So right now, the MailChimp AP, which is in that back corner, concurrent connections. And that's right now. And the access point right over the Google AP has 25 connected. So you're probably one of those 25. And once we pull this out to the full picture, you can see when people are coming and going and what access point they're connected to as they move around in the conference center area. And so you can start trending on this. You can start developing trends on, when are, on your own network, when are people using it, when are they hitting it, and how much traffic they're using. This next one is the signal strength. Signal strength is very important in wireless because it will affect your speed and the experience and the latency that you experience on your wireless. And so this is basically a percent chart of per AP how many people have either good signal level or poor signal level. And that's done per AP. And I'll show the graph. So you can see that for the most part, most of our access points are doing quite well. Most people have very good signal, and that's because we have so many access points. I did kind of pack them in here. And so this is just the per traffic. Room count's actually very interesting. So when you are moving between access points, that's called roaming. That's the wireless roaming. And I'll get to a little later technology that we use called minimum RSSI, which helps in this roaming. But this is really cool that between changes in rooms, you can see as people move between access points, because this will tell you which access point they're leaving from. So when you leave an access point and join another access point, your MAC address is registered on that new access point. And this will basically keep a chart of how many times that MAC address has moved. Also the chart also exposes the connection. This is a connection per client. So you can see that there's a device that's been connected to the bar AP now for 12 hours, which they had a late night. And the last one is, in wireless technology, the signal to noise ratio is very important. The more noise you have, the worse your environment will perform. And so this is just a chart of the noise levels per AP. And the noise levels, the reason they fluctuate is because as you add clients, they produce noise. So because they're transmitting on the same frequency that the access point lives on, they are creating more RF spectrum, more RF noise. So as more clients get packed in, or someone fires up an AP and it's sitting on the same frequency as my AP, it will contribute to the noise. But for the most part, the noise has been very stable. Questions? All right, so Unify. It is free as a beer. They do not charge for it. It is a Java-based with MongoDB-backed application that they officially support Ubuntu and Debian, but I have seen people get it working on CentOS and FreeBSD.
There's also an Android app.
Yes, there is an Android app which can be used to control the access points. I believe even with the app, you don't even have to have the controller. You can control the access points directly. But I have not used the app itself since I'm used to using the controller. And here's the controller itself. And so you can see, here's all the access points that we have, their firmware versions. I can reboot them. What the locate does is the locate AP, the locate will basically, if you look on the access point, I'll hold it up. It turns the LED into a flashing light. So if you have, if you go, darn, I don't know where that access point is anymore, it's mounted on the ceiling, you turn locate AP on, and you walk around looking for the flashing AP. It's a lot better than trying to use a Wi-Fi sniffer and guesstimate that might be the access point. Here, I'll turn it back onto the video. And so you can also tell it to reboot the access point. So say maybe there's a configuration issue or network change or something like that. You can tell it to reboot. You can also see all the clients that are connected by their host name, or if they don't present a host name, their MAC address. Anyone want to volunteer for a demonstration? What is your IP address? I just need one.
I'm 0.138.
138.
But I'm in the middle of a network scan right now.
Good. I'll block you. Alright, so I had just blocked him, and so he was just immediately disconnected from the wireless network.
Oh, it finished.
He might not.
It didn't really finish, it just found out it.
Yeah. So basically, what the access point did is just shut him off the network, and now he will not be able to reattach with at least with that MAC address. He could spoof it, but most end users don't know how to spoof their MAC address of their device. I'll be nice and let them back on the network. And you can also then get statistics. So since he's the whooping boy at this point, here's his connection history and how much he downloaded, how long he was connected, when he connected. And you can get this on a per client level. And then even here's where you can put an alias. So I could say, hacker. So I can also change his user group. His user group basically is defined what speeds he can get. So I could throw him in the no cap group, and he would then no longer have a speed cap. And I'll show you the speed caps in a second. Here's the statistics. This is a dumbed down version of the statistics that I was showing earlier. Because these statistics are limited, I opted for the Zabbix. And so you basically see per AP, who's connected on what network, here's per AP on where people connected, who that most active people are, access points and stuff. And so I was talking about speed caps earlier, and here are the speed caps that are actually enforced right now. The speed caps I use for two things: so users could not abuse the system, and so I can do some social engineering with it. 2.4, particularly at a conference like this, is very trashed very quickly because of access points that people may bring in, hotspots, tethered devices, and such. So I wanted to encourage people to get on the 5 gigahertz network. So I made 3 public networks. I made self-public 2G slow. So this is a 2 gigahertz only network that I told everyone will be slow. And it is slow. It's got a cap of 8 by 1, which is actually still pretty good for a conference Wi-Fi. The next I used is I did self-public mixed band. So this is a 2.4 and 5 gigahertz network, which will, and then the system will then band steer clients. So basically, the system will try to convince the clients to connect on the 5 gigahertz. And this doesn't require user intervention. This is the AP talking the wireless protocol to the client. So come over to 5 gigahertz. And that particular one has a speed cap of 12 by 1. I then made a 5 gigahertz only network called FAST. And if you saw from the previous slide, the vast majority of users are on the FAST network, which is great. That actually has a cap of 50 by 2. And I did test that earlier, and I was getting the 50 by 2, which is really good for a conference. Another feature.
It's actually much better than the hotel network.
Oh, well, thank you.
And SSH isn't blocked.
Really, they block SSH on the hotel?
No, I don't. I think it was my VPN that was blocking it. When I joined a hotel network, I always bring up a VPN.
So, funny thing about the hotel, hotel has basically 1 or 2 access points for every room that they have on this side of the building. So they have like 20 access points, and they're all cranked up way too high on the RF power. So last year, I actually had the hotel when we come. Shout out to Kevin Frost, the building maintenance guy for this building. He's amazing. He actually, this year and last year, actually went to the PoE switch and unplugged all of the hotel's APs on this half of the building. So there is no hotel Wi-Fi in this half. So that's one of the reasons why I was able to have such a great network. One last thing before I leave the Unify software is here's all the, they can call it rogue access points, basically access points that are within range of my access points. And so I can see what their location was, what their signal strength was, what type of security it was, what type of manufacturer it was. And this can be used as part of the security protocol to basically keep an eye on the access points in your building so that employees don't bring their own.
Did you happen to draw the map and put the access points in the map?
So, no, I did not do it inside the software. I just took one of the programs and took a pen and drew out and channel planned it. And the question was, there's a map function here which allows you to drop the access points on a map. This could be a PDF, it could be a Google Street View image or Google Maps image. So that's the Unify side.
Well, and it'll give you an idea if you put an access point on there, how far it'll reach, so you can see where there's overlap and maybe.
Yeah, that's an estimation. So, because I did not actually end up using pfSense, I'm going to kind of skip this. Like I said, pfSense is a open source based firewall based off of FreeBSD. Here's what I actually did end up using. This is the Edge Router Lite. Like I said, it's a $100 router. This is one of their features called DPI, or Deep Packet Inspection. It doesn't actually pierce SSL or any type of encryption. Basically what it's doing is looking at the source, destination, port, and IP, and the protocol type. And on the destination it will look up the domain name to find out whether it was Facebook or Google or something like that. And so you can see, like this particular client right here, 84% of his traffic is from Young. So apparently someone is updating their RDM base box. These are basically the top clients that are on the network right now. And you can see a percent of traffic on what each one of these different clients is doing.
What's that big one over to the left?
This one right here?
Oh.
Yeah, that's the other. Basically, anyone that didn't make it over a threshold, and it just kind of groups them all together. So tips to making a great wireless network. I touched on minimum RSSI earlier a little bit. RSSI is, in the way it's implemented in Unify, is you basically take the noise floor, which is, in our case, it was like negative 104 dB, and then you subtract away the signal to noise ratio. In this case, in our case, it's about 40 in most cases, and that will give you a numeric number. In my case, I'm using 75. And so if your signal level is below 75, as perceived by the access point, so that's a client signal level talking back to the access point. If you're below 75, meaning worse than 75, the access point will kick you. It'll kick you off of it in hopes that you'll reconnect to another access point that you have better signal of. Clients are very sticky to the access point that they join. They do not want to change. Because it does technically mean you will drop some packets when you change. But that is better than being on a fringe network and having very high ping times. So like I said, the access point will kick you and hopes that you join. If you are truly on a fringe network and you cannot see an access point, the access point will just keep kicking you over and over and over and over. At some point you'll get pissed off and either walk closer to the access point or walk farther enough away that your device no longer tries to connect. The next is power levels. The worst thing that you can do in a multi-access point environment is turn everything up to high. Because that makes clients stick to access points longer. It produces more RF energy in the air. And back to the earlier when I said the signal to noise ratio is important. It is important because the higher the signal to noise ratio you get, the higher the modulation is. The higher the modulation, the faster the transfer speed is. So you try to keep everyone as high as possible. So that's why if you adjust the power level such that you can get people to be in a certain zone. The other thing I do is I set my power levels different for 5 gigahertz to 2.4. 2.4 has great penetration through walls, through objects, where 5 gigahertz doesn't, but 5 gigahertz is more bandwidth. So I'll typically, in this case, I have the 2 gigahertz on low and the 5 gigahertz on medium, so that it helps balance out so they have similar ranges. The other thing is clients will typically choose 2.4 over 5 because the client perceives the signal strength to be better on 2.4 because of the range issue. So by bumping the levels up, you kind of trick the client into thinking the 5 gigahertz is actually better. The next is dual band. Absolutely use dual band in a dense environment like Southeast West. I use dual band at the house, and I never, I got about a dozen devices, up to a dozen, and it works great. And particularly in apartments like I'm in, I have something like 32.4 gigahertz access points all around me. There's like 5 gigahertz. So 5 gigahertz can go a long way in an urban area. The next is band steering, I talked about that earlier. That's where the access point and controller work together to get the clients to use 5 gigahertz over 2.4. Then I touched on social engineering about using the different networks to try to get people onto the appropriate 5 gigahertz network. And channel planning. Do not trust auto. And very few access points can do auto channel great. Most times, what auto means is when the unit boots up, it will pick a channel and stay on that channel until you reboot it. It doesn't change if environmental parameters change. So that's why I always hard fix them. Yes?
I'm noticing that the 5 gigahertz is all on a single channel for all the APs right now.
So that is, you probably see just a single AP. All the networks, all the 5 gigahertz networks that come off a single access point would be transmitted on the same frequency because it's the frequency is determined by the access point. So that's probably what you see.
I'm using a Wi-Fi analyzer,
Mm-hmm.
and so normally it shows multiple IPs if it can reach them. And
Let's take a look at that. So in channel planning, in 2.4 gigahertz, you really only have 3 channels to pick from. Yes, there are 11 channels, but you can't actually use all 11 channels because of overlap. So in the US, there is 1, 6, and 11. And that's it. If you decide to be a dick and put your access point on 4, you're actually picking up more noise because you're sitting on 2 channels. You're sitting on 1 and 6. And so you're going to pick up noise from 1 and 6. Where if you put your access point on just 1, you're only going to pick up on, I believe it is 1 through about 4. And so if you put all your access points on 1, 6, or 11, you can, with those 3, you can typically get enough separation that they're not completely stomping on each other. On the 5 gigahertz, you got a lot more channel space. Using 40 megahertz channels, I think there's about 8 that you can choose from that don't overlap. And these are tips for just networks in general. Use lag when possible. Lag is link aggregation. Basically, where between 2 switches, you can run 2 cables, and say these are gigabit only switches. So between the 2 switches, you have 2 1 gigabit links. When you link aggregate them together, they act as a single cable, a single 2 gig cable. The reason you want to use lag is lag respects spanning tree protocol. Spanning tree loop protocol is a loop prevention protocol. So if you take those two cables between managed switches, let me clarify, managed switches, and you run those two cables without lane irrigation, spanning tree will shut down one of those cables to prevent a loop of traffic, particularly broadcast, and that's called broadcast storm. So when you do link aggregation, to STP's point of view, that link aggregation cable is a single cable. And then also, when it does packet ordering, link aggregation can really help throughput. Next one is a bane of all network and sysadmins, is documentation. Documentation can be a fickle thorn. I'm not in favor of documentation in the form of writing everything down on an Excel sheet or a Word sheet or whatever text format you want. I'm of the mindset that documentation should be dynamic. So, for the example of how do you know which cable you have plugged into a particular port on a switch? For me, I use the switch port description. So I'll log into the switch and set the description. What that does is any SNMP-based monitoring platform that you use will pull that description. So now you don't have to go to your Word document, edit it, go to your monitoring platform, edit it, and go to your switch and edit it. You log into your switch, you make the change, and your monitoring platform picks it up automatically. On the same vein, in my own networks, I always run reverse DNS lookups. So that is the pointer record. Basically, on any of my systems, I can go in to any computer and do an NS lookup on the IP address line. What is this IP address? And I'll just do an NS lookup on the IP address itself. And the DNS server will spit back, well, that IP address host name is blah, blah, blah. And that typically will relate to its A record. And so then that can be used as your documentation. Then if you run a IP management software, which is pointer record aware, you basically just go into the ICANN software and say refresh, and it will do the lookup for you and populate the documentation. Another is with documentation is if you enable like Cisco CDP or LDP, which is Link Layer Discovery Protocol, basically allows switches to discover themselves when they come up on the network, and that will tell you what port they're on, what port the other switch is using, and a lot of parameters will be shared among the switches, which then the monitoring platform then can pick up. Firewall rules, I know a lot of businesses and people do not use firewalls between corporate VLANs. You really should. There was a talk earlier about do not trust your corporate network, and that is 100% true. Just because you think you have full control, you do not. So lock down access to the least that is needed to accomplish the task. So if you know that you don't need to be SSHing in from these different IPs, firewall off so that SSH is locked and logged, so that you can have in your monitoring platform, you can have an alarm of when someone tries to SSH from your server from your wireless network. VLANs. Some people think VLANs are not security. I am of the opinion they are, because they create someone called it earlier, a logical boundary between networks, which then allows you to use firewalls from above. VLANs, if the switch is configured correctly, actually can be security. And there's been some talk about where if you go to a managed switch, you can basically spoof the VLAN tag and jump the VLAN barrier. If you set up the switch appropriately, that's not possible. So they can be used for security. And QoS. QoS I have a love-hate relationship with because it can create problems, it can create headaches, it will add latency. QoS is really only needed if you think you're going to have a network link that is going to be overutilized above its capacity. And in most corporate networks, there are no links. There should be no links inside the organization that regularly hit over 80% utilization. If they hit over 80% utilization, you need to think about putting an upgrade in, whether that's upgrading from 1 gig to 10 gig or 10 gig to 40 gig or 100 gig. So I typically do not run any QoS in any of my environments. You could sometimes run QoS on the LAN. I typically don't because, again, it will add latency. And depending on what queuing policy you use, some queuing policies will only take effect if there is high utilization. Other queuing policies will take effect whether there's no utilization or not, and can actually artificially slow down your traffic because it thinks it needs to. So here's where we get to the AV stuff for self. This year we're using OBS, or Open Broadcast Studio. It is Floss, free open source Libra software. That is actually doing the recording. That is doing injecting the pre-rolls and injecting the ads at the end. And it's also doing the switching between the different video sources, whether it's the camera or the screen. For the screen, to get the slides from this laptop I'm using to his laptop, we're using X2Go, which is the X2Go server lives on the laptop and the client lives on his laptop and basically establishes a connection over SSH. And in a LAN environment, we have not had any problems with it. Questions? Yes?
Just curiosity, Time Warner is your ISP, from what I can see.
For the event, yes.
Yeah, did you guys contract for that for self, or?
Yes. So the question is Time Warner our ISP for the event? Yes. TWC is our internet connection. They are the only ones that could deliver a high-speed connection with no contract. So we basically paid, it was $600 plus a $200 install for our connection to use for 3 days.
100 megabits or something?
It's 300 down, 20 up. And technically we have it for almost another month. But they wouldn't just install it for 3 days. Question?
Any tricks with X2Go to get the desktop sharing?
I did not configure the X2Go, so I cannot answer that. The question is, are there any tricks for X2Go?
I use X2Go every day. Constantly.
Okay, I can only barely comment about that. I'm video guy here. I know we had some trouble in the next room over the Oracle room because the laptop was different than the rest of them. My understanding is I didn't set this up. These laptops here are Gen 2 systems that Jeremy set up. From what I saw, it was install X2Go and it just worked. I have never used it, so I really can't comment beyond that.
So I've never used the client-server connection. That was kind of my question.
Okay.
How do you do
My understanding is with some of the presenters that brought their own laptops, he was talking to one guy that had an Ubuntu laptop, and it was basically get install and start service. That was it.
Yeah, I know how to make it work, but I don't know how to do the remote connection from a client.
Talk with Jeremy.
I'm sorry. I'm freaking out. Okay.
Talk to Jeremy. I don't know.
Yes.
Are you ready for next year?
I'm gonna need a break. So funny story is Jeremy loaned me a server to use for PFSense. It did not have RAID, and the hard drive crapped out Monday. And so I lost the backup. I lost all the configs for it, and so I had to rebuild the server, and I was up way too late doing that.
Anything you'll do differently next year from this year?
I'm actually going to try to go. I like the integration that Ubiquiti has. If you do an all Ubiquiti network, particularly if you use their Unified Security Gateway, the DPI, deep packet inspection, is even more advanced in the Unified platform. And I want to get a Ubiquiti Security Gateway Pro, which is their rack mount version, and that thing will scream here. The question is there anything I would do different? As far as the wireless network, it's been great. We hit our peak yesterday was 170-ish concurrent clients, and during a wireless bandwidth, we hit about 110, 120 megabits down, 20 up. On the wired network, in aggregate, we hit about 150, 160 megabits down. Also, I'll get to the question in a second. We had, last time I looked, we had over 400 unique MAC addresses connected to the network, which it's kind of high, but it's kind of low at the same time because I know at least for me, 3 of those MAC addresses were my devices. Yes?
How long does it take you to set up and tear down the?
So the setup, I got here Thursday at 10 o'clock. I already had, so let me go back. Question was how long does it take to set up and tear down? I got here at 10 o'clock Thursday morning. I already had the switches configured, the servers configured, and the router configured. I think I just squeaked in getting to bed by midnight. It took 4 or 5 hours to run all the cables because all the cables had to have ends put on. I was fortunate that the hotel doesn't do any construction, hasn't done construction this part of the building in 3 years. So the first year, the company I was with installed cabling in the ceiling that ran from the command center out to the various points. And so when I got here this year, I popped the ceiling tile open and found my nice coil of wires up there, and I had the zip ties, so I just cut the zip ties and dropped them down. And even the labels were still intact, which I was amazed, and so I just plugged them all in the switch. As far as the teardown, it will probably be 3 to 4 hours to tear this all down and get all the equipment packed up, get all the cabling removed. Y'all want Ethernet cable, there'll be a pile of it sitting outside this ballroom as soon as the last talk is done with.
Can you talk about the audio setup a little?
So, I'll talk about what I can. The audio setup uses a 2-channel mixer. One of the channels is from the wireless mics. The other channel is coming, I believe, from this laptop over RCA. The output then from the mixer board, one of the outputs is sent back to the back for the speaker. The other output is sent as a mic in to the laptop to be recorded in OBS.
The audio from the camera is not being used at all in OBS?
It's technically is detected, but it is not being used.
We've had some mic problems in some other rooms where
They may have fell back on the high-end Logitech webcam that has a shotgun mic.
and they're the 920Cs.
I would have to look. And so I think they have fell back on the USB audio. You have a question?
Well, yes. Which of the okay, rephrase. Wireless access point at home. Which one would you recommend and which one would you stay away from?
So like I said, I'm very bullish on the Unify platform. It's very great, very cost effective. I in fact use an AC Lite. It is about an $80 or $87 access point. It's got PoE, dual channel, wireless AC, wireless and backwards compatibility, and it's PoE. And the controller software is free.
And don't get it all in one device. Buy a separate AP and plug that into a wire.
Yeah, because typically where your internet connection comes into is not the best place to put an access point. They're typically, access point maybe is upstairs in the middle of the house, and your internet comes into a basement or something. And so if you can separate your access point away from your internet connection, your router, then you can typically vastly improve your performance. And the Unify platform, if you have a larger-ish house, then you can put multiple Unify access points and have a multi-access point network and have no problems with speed.
Or if you're on like a campus, you could use the long range version and cover 600 meters away from your house in all directions. They're really not directional, so they're just setting on the full respond.
Yeah.
Related, how do they handle concrete walls?
The question is, how do access points handle concrete walls? Typically, not at all. You typically will put an access point on both sides of the concrete wall to get coverage. The common, on the ubiquity forums, you see a lot of people posting, how do I get internet into this particular hotel? And you start questioning of like, what's the design of the hotel? And they'll tell you that all the walls are concrete block that's been filled in with concrete. And you basically tell them access point in every room is basically what it takes. RF, particularly 2.4 and 5 gigahertz, does not penetrate concrete in the back.
Have you used the wall plates or the top yet?
So the question is, have I used the wall plate access points? No, but they look like a freaking amazing product. Basically what the product is you see these wall jacks down here that the hotel has for their internet? Basically, Ubiquiti makes it fits in that form factor access point that you just slide right in, PoE powered. Then it also has a PoE output port so that you can power like a PoE phone. So that's how you can retro mod a hotel, is using the in-wall access points.
Nice.
Any other questions? All right, thank you for coming.
And nice job on the networks. Best
When we were trying to name Google, we actually went through thousands of names.
The name of the company has now become its own verb in the dictionary.
Let's Google it.
You can Google it.
Work the Google on the internet machine.
6 simple letters on a plain white page.
Being able to do searches in any language about any country.
The thing, when you're putting in a question, they'd finish your question for you.
We have been working on organizing the world's information.
Our goal is to digitize all the books.
Today, Google announced Gmail. Email for everyone for free.
Google is mapping the entire world to make it more accessible to people everywhere.
Google is jumping into the mobile market.
Android was built as an open platform for everyone to use and build on.
This is Chrome. It's a faster, safer browser for the open web.
Google is unveiling what they call the knowledge graph.
We needed to understand the world the way you and I do, as objects and relationships between objects.
Today, Google got another useful feature with Google Now.
We are providing you with answers before you've even asked for them.
One of my favorite cards is the one that shows traffic data for your commute to and from work.
Think about how far Google has evolved from the 10 blue links.
We asked ourselves, how can we assist you right when you need it?
Okay, Google, call the Walker Art Center.
It's not just desktops, phones, and laptops anymore.
Okay, Google. 유진이한테 5분 늦는다고 문자 보내줘.
It's watches with displays, car consoles with displays.
Okay, Google. Let's go to the aquarium.
How can we help you get things done in as few steps as possible?
Okay, Google.
Okay, Google.
Okay, Google. Show me my photos of Lucas with the pumpkin.
But we have to remember, we have a long way to go.
This is just the tip of the iceberg.
second show. Your guitar, it sounds so sweet and clear, but you're not really here. It's just the